The following is a video over 3.5 trigonometric limits. Because we are studying limits, we want to make sure that we hit the trig limits, but we had to go a little bit out of sequence. But the important thing in this section is this theorem 3.11, and these are trigonometric limits. And these are kind of some special cases when it comes to limits. Both of these limits are indeterminate, but they actually have values. So, you know, if I were to do direct substitution on this and plug in 0 to sine of 0, it would give me 0 over 0, which doesn't equal 1, okay? But I'm going to kind of show you guys how we get these limits. So what we're going to do, we're going to do the table method. And the first one we're going to look at is sine of x over x, and I'm going to put in values for x and see what values we get for sine of x over x if I plug those in. So I'm going to plug in, say, negative 0.01, negative 0.001, and negative 0.0001. Okay? At 0, I know I'm going to get an error, okay, because I can't divide by 0. But then I'm going to plug in 0.0001, 0.001, and then 0.01 and see what we get here. I'm also going to do the same thing for cosine, or this other one, cosine of x minus 1 over x. So I'm going to plug in values for x, and it'll give us values of cosine x minus 1 all over x. Okay, so I'm going to plug in negative 0.01, I'm going to plug in negative 0.001, negative 0.0001, 0, that will give me an error, and then 0.0001, 0.001, and 0.01. And we're going to see what y values we get, okay? So go ahead and plug both of those into your graphing calculator. I've already done that. If you want to go ahead and pause the video and take time to do that, please do so. But what I need to do is I'm going to take a look at the table real quick. And notice that on both of these at 0, they say error. Okay, so the functions are cannot be evaluated at 0. Okay, because you're dividing by 0 if you plug in 0 into those functions. Okay, but let's go into our table. Okay, and let's make sure that we change this to ask. Okay, and I'm going to do both of these at the same time. So I'm going to plug in negative 0.01, enter, and so we get 0.9998 and then 0.005. So I'm going to plug those in, so we get 0.9998 and then we get 0.05. Okay, and then let's go back. Let's plug in 0.0001. Right, I don't know, 0.001. And then let me change that to delete that one. And go ahead and hit enter. And look, guys, this pretty much just goes ahead and just gives me 1. Okay? Since we are so close to 1 already at negative 0.01, that as we get closer and closer and closer, the calculator is just going to say 1. Okay? And then this negative 5e to the negative 4, that means that I've got 4 zeros before I get a 5. Okay, so that's really, really, really small. So that's like 0. This is like 1. So actually, you know, this basically becomes 0.99999. This becomes 0.99999. All right, and add another 9 in there. And so it's getting really, really, really close to 1. At 0, we have an error. If we went on the other side, it would be mirrored, and we would have 0.99999, and then this would be 0.99999, and then this would be 0.9998. Okay? So what you can see here is that as we get closer and closer and closer to 0 from both sides, we end up approaching 1, and that's why we get that value there. Okay? Same thing is going to happen here. If I plug in all these values, I'm going to get 0.00005, and yada, yada, yada. Okay, the numbers get really, really small. They get really, really close to 0. As we approach 0, we have an error, okay, at 0. But as we approach, we're getting really, really close to 0. okay? And the same thing over here. This is, I think this is negative, I believe. Yeah, it goes down, so it's actually negative, but it approaches 0. Negative point 0, 0, 0, 0, 0, 0, 0, 5, negative 0.00005, and negative 0.05. Okay, so these values are getting closer and closer to 0, and that's why we have that this limit value equals 0. Now, guys, if you simply just look at the graph, all right, let's just look at the graph right here. Here's the blue function. Here's sine of x over x. What happens as we approach 0 from the left and from the right? We get 1. Okay. Here, as we approach left and right on cosine of x minus 1 all over x, we approach 0. There are holes here. Okay, those are undefined at those values. However, we can look at it graphically. We can look at a table of values and see what's happening. But when we see trig limits, okay, and if we get some trig limits that we're not able to evaluate by direct substitution, then we need to use some manipulation on them, but we need to try and get these trig limits, okay, because these are the ones that we know, all right? So the main thing that I want to show you, this is the one that's going to pop up the most, but if I have the limit, so the limit as x approaches 0, of the sine of x over x, that's going to equal 1. Okay, now the important thing that I want to show you here is that we might have values here like sine of x, if this is an x and this is an x. Okay, so the important thing to see here is that if these values match, okay, if your angle measure is the same as your denominator, then the limit will always equal 1. Okay, in this scenario, will always be 1. All right, so that's something that that's a 1. That's something that I want to make sure you guys see. We'll do some examples on this. I'm going to do another video because I don't want to make these videos too terribly long. But we'll talk about other ways why this works in class. But these are the important ones. You really need to memorize these because if we have these trig limits, they will pop up and they will show up. So see you in a minute for another video.